Okay, this is a geometry lesson on the basic building blocks of area. We're going to talk in this lesson about triangles, parallelograms, and trapezoids. Well, let's talk for a moment first just about what it means to have area. Got some basic, look at this, postulate. It's been a while since you saw a postulate, hasn't it? Okay, so the first one up. It's incredibly obvious, incredibly simple, but incredibly significant. So let's talk about it for a minute here. The area of a square is side squared. You're saying, like, really? Did she just say that like it was important or like it was news? Oh, it is. It is. Let's think about it. All area is the unit square. Length times width is 1. It's s squared. It's 1 times 1. It's 1 squared. It's 1 unit square. We do all area in this. That means if I got something that's not square, I got to fix it so I can cut it up. Like, for example, if I've got a rectangle, I got to make that into squares. So I could do something like this, and I say, well, look, I just made 8 squares. This must have an area of 8 square units. Oh, there it goes again. Square units. Okay. Well, what if I had a triangle? We're going to talk about those, and we're going to slice it up. What if I had a circle? We've got to slice it up into squares and figure out a way to copy it. To count it. That's what we're going to do because all area is based on the unit square. So, an important principle, although it really seems kind of simplistic. Couple of things here about area. Polygons that are similar have this, polygons that are congruent have the same area. Polygons that are congruent have the same area. That kind of makes sense because they're going to have the same dimensions and you're going to calculate it the same. Yeah, that makes sense. Okay, well, what about, is everything that has the same area congruent? No, because you could have a circle that has the same area as a square. And just because they have the same area doesn't mean that they are congruent. Okay, once again, our sum of the parts as a whole rears up and helps us out. It is true in two-dimensional figures, area, that the sum of the part is, of course, the whole, and obviously that means they're not overlapping, but you knew that, didn't you? Okay, let's look at a couple of things here. The area of a parallelogram. Couple of ways to think about the area of a parallelogram. Okay, there's a parallel. Okay, what did I just say? I just said that we're going to cut it into a square. Well, I'm looking at that and I'm not thinking square. When I look at that, I don't just say, that's a square. So I got to figure out a way to make it square. And here's what I'm going to do. I'm going to lop off this end so that it's square. Now, well, I'll have part of square anyway. Okay, so there it is, and I got part of a square. Okay, now somehow I got to make this all thing into something that's, well, if I had a rectangle. If I had a rectangle, then I could just slice it up like I just did. It'll be really easy. Oh, look. No. Rectangle! Yay! Okay, so now that I've got a rectangle, I can just do length times width, slice it into unit squares. That's what length times width is. Have you figured that out? Okay. So this is, say it goes this way, 2 units by 3 units. This has 6 square units. There it is, unit square again. Unit square, square units. Okay. How did I do that? Okay, I made it into a rectangle because I know that once I've got a rectangle, life is easy. I can just do a little slicing and dicing, and I will have my area. Okay, so what did I do again? I had a parallelogram. I said, gosh, I need a square. If I only had a rectangle, I could slice it, and then I'd have a bunch of squares, and I'd be done. So I started kind of making me a right angle, seeing what I could do, and then move it right over there. And yes, it works. I can find it that way. Now, what's the area that's going to be? Okay. It's going to be 3 units times 2 units, or 6 square units. Okay, now look really carefully how much blue paper there is there. Okay. Watch out I don't mess up with you. Okay, has any blue paper been created or destroyed in the messing around with this parallelogram? No, it has not. That's the same amount of blue paper as it was when it was over here. How did we do the area of the rectangle? Length times width. How do we do the area of a parallelogram? It's still length times width, except we use that pesky triangle language and we call it base and height instead of length and width. It doesn't matter. One's just the bottom and the other's just the distance between the two bottoms, right? Okay? So in a parallelogram, you can have it. You can call whichever one you want the base because it's going to work. And then you have to remember that height is always, always, always perpendicular. Okay? Ooh, y'all didn't get to see me stand all crooked. I do this little thing for height. But anyway, height is always perpendicular. It is not this edge. And you're saying to yourself, oh gosh, what if she get over this? But trust me, some of y'all are going to make this mistake because you're just going to be in a hurry. So height is perpendicular. It's the perpendicular distance between the two bases. That's the height. Okay, let's look a little more conceptually at how it works with a parallelogram. Make sure you can kind of see how it works. Okay, I'm going to make a parallelogram here with a handy dandy little green sticks. Okay, imagine that that's a parallelogram. Okay, and I want to find the area of the parallelogram. Again, I remember, if I had a rectangle, I'd figure the area. Ooh, that was really bad. I'd figure the area all over this land. Okay, bad, I know, bad. Okay, if I had a rectangle, I can do it. Because I have a rectangle, I can just slice and dice. I'll have unit squares, and that'll be good. So I would like for this to be a rectangle. Okay, well, I'm just going to make it a rectangle. Watch carefully to make sure I don't mess with any of the green plastic. Look here. There we go. Now the question is there the same amount of green plastic there as there was before I started moving it? And the answer is yes, there is. So, again, here we have a rectangle. Length times width equals area. The reason for that is we can slice it up into units, slice it up both ways, and then just count the squares. We'll make squares by slicing it and then count them. Okay, again, when I make this thing crooked, it becomes a parallelogram. And what you see here is that it still has the same amount of green plastic. Now we have what was the length, and the height, of course, has always got to be perpendicular. And we don't really call it the width too much anymore. We just kind of use the other terminology, base and height. It really doesn't matter which ones you use. Okay, so what do we have there? We have some handy, oh, triangle. I didn't do triangle. Okay, so let's look at the triangle. A reminder, every triangle is half of a rectangle. It's half of the rectangle that can just barely be drawn around it with the 3 vertices. So, well, you're saying to yourself, really? Okay, well, how would that work? Okay, this triangle is half of the rectangle. That's right here. Okay, so I'm drawing a rectangle around my triangle. And what I'm purporting to tell you is that that triangle is half of that rectangle. Well, how am I going to do that? Well, let me see. If you look right here, okay, triangle and triangle. Okay, that made the rectangle, right? Yeah, but what am I going to do with those? I'm going to cut them out. So I'm going to take these two little pieces. Okay, now what do I have? I've got a crooked one, and I take the ones that I do, and I turn them. What did I do wrong? That one works. There we go. And that one works. Okay, so we put them together, and we make it. Okay, so what did I do? Okay, I had a rectangle. I had a rectangle. I can do a rectangle easy. Rectangle is easy, 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 easy. And so I knew that if I could do some way to relate this triangle to a rectangle, then I was done. I was home free. Made in the shade with glass lemonade. So, I noticed that the rectangle that it'll just barely fit into. And then I observed that the leftover portions that were not inside my triangle also made a triangle that's congruent to it. So I have two triangles that are the same, my original blue one, and this one that I've just cut that's the same. A piece goes here, and a piece here. Oh wait, these are the same. Since they're equal, there are two equal portions that make up a rectangle, so each equal portion must be half. So this triangle is half of the rectangle that it just gets into. That's true of all triangles. It works no matter what the shape is. So now we have time for a trapezoid. Now we did the trapezoid. If you've got your notes from back when, we did a whole bunch of work on a trapezoid. I'm going to remind you of it, how it worked. What we did is we dropped altitudes from the upper base to the lower base. Then we found halfway in between. Hopefully you're remembering this, or you took your cipher home and you can look. We found the distance halfway in between. So, okay. And we observed that this distance is the average of the bases, or add them up and divide by 2. Happens to be this distance. Again, all area is a unit square, and if you can have a rectangle, it's really easy to cut it up into unit squares. So if we could make a rectangle out of this, life would be good. And we can. We'll cut off the part that's past the average. Remember, we did this in class doing this, and I'm just reminding you. And then we get our unit square. Excuse me, we get our rectangle from which we can slice it into squares and have a unit square. So again, what did we have? Remember, you did this yourself in your cipher. We find out the average of the bases, the upper base and the lower base is this distance. We cut off what's beyond the average and flip it up to see that we have a rectangle. So then what's this is the height of the rectangle, or the width of the rectangle, the height of the trapezoid. The base and the length are here, base 1 and base 2. So this now is the average of the two bases. That's the one we use, is the average. If we talk about it in rectangle form, it'll be the average length. And this will be, and the height will be the width. So we just get a bunch of terminology here. And so what we have is the formula for a trapezoid, which you're familiar with, but we just derived it. And here are all these formulae. Okay, need to make note of these if you have your cipher. And I certainly hope you took your cipher home. If not, we'll try to help you out. And if you need some help, you can ask me what you might need. Okay, so go ahead and write these down again to make sure that you're remembering them. Remember, it just helps you to write things to get it into your brain really good. The area of a rectangle is base times height or length times width. You can say it any way you want. All of these are based on a whole rectangle like we just did. Parallelogram, base times height. Area of a trapezoid is the average of the bases times the height, or our formula, which is usually written as base 1 to half of the sum of the bases is the average times the height, and then that's how the formula is usually written. And then every triangle is half of a rectangle. And so here endeth the lesson, and Froggy says, see you next time. Doggy says, see you next time, guys.